Welcome to fluid mechanics. So in this session we are going to discuss about dynamic viscosity and kinematic viscosity. After that we are going to solve few problems related to kinematic and dynamic viscosity. So till now we have discussed about the few fluid properties like density, specific weight, specific volume, specific gravity, and we have solved some numerical problems related to few fluid properties. So now we are going to the fifth property, that is dynamic and kinematic viscosity. So first, what do you mean by viscosity? So viscosity is normally it is a property of the fluids by virtue of which fluid offers resistance against the flow or a shear deformation. So when the fluid is flowing, so how much resistance it will get against its flow or against motion. So the resistance when the fluid gets while it is in motion, that you can call as a viscosity. So normally the viscosity is majorly because of the cohesive force. So the viscosity is majorly due to the cohesive force. When the fluid is flowing between the two layers, so the fluid will flow in a layer by layer, right? Fluid will flow by layer. When one layer passes over the other layer, the molecular attraction between the two water molecules, that you can call as a cohesive force. So because of the molecular attraction between the same molecules, for example, this is the one water molecule and another water molecules, when they flow over one over the other, so this molecule will attract, because of the cohesive force it will try to attract the other molecule which passes over it. So these two molecular attraction between these two layers you can call as a cohesive force. So the cohesive force is the major reason for viscosity in the fluids. So when it comes to the gases, the molecular activity between the fluid layers, that is the major cause for viscosity. So another important property is adhesive force. Adhesive force means the molecular attraction between the different molecules. When the fluid is contact with the solid surface, so then what will happen? For example, this is the solid surface. Yeah, this is the solid surface. So when the fluid is contact with the solid surface, so this solid particle will contact with the fluid particles. So fluid particle is different from the solid particles. So the molecular attraction between the two different molecules, that you can call the adhesive force. So which is also plays an important role in fluid mechanics. When you try to understand the fluid, fluid characteristics, then we have to understand these two properties. One is cohesive force and adhesive force. The cohesive force is the major reason for viscosity. So viscosity are two types. One is dynamic viscosity and kinematic viscosity, which we will discuss in detail in the coming slides. Yeah. Now we are going to deal with Newton's law of viscosity. So what is Newton's law of viscosity? First, what is Newton's law? We all know there are three Newton laws. Actually in the fluid mechanics we are going to use second Newton's law, that is when the body is moving. When the body is moving in a path, so it will flow. Yeah. Newton's second law of motion, F is equal to ma. So it will indicate So unless you apply an external force, the body will be in the same motion. It will continue its rigid motion. And the fluid is, when the particle is moving with some velocity, so it will be moving with the same velocity until you apply an external force. So until you apply external force, that is F is equal to ma, the force acting on the body will be equal to the mass of the body into acceleration of the body. So this is the Newton's second law of motion, and actually which we use to derive the many equations in the fluid mechanics. So the Newton's law of viscosity, that means actually Newton's law means here Newton's law of fluids, the fluids which obeys the Newton's law of viscosity, that you can call as a Newtonian law, that we will discuss in detail later. So first, to derive the Newton's law of viscosity, so I have considered fluid flowing between the two plates. One is fixed plate, so one is fixed plate at the bottom, and another is movable plate. So another is movable plate. So in between the two plates, the fluid is flowing in different layers. Okay, the distance between the two plates is y. The distance between the two plates, is y. So the distance between the fixed plate and the movable plate is y, right? And the area of the plate, whatever the area of the movable plate is A. I have considered the area of the movable plate is A. So F is the force acting on the movable plate. So F is the force acting on the movable plate. Right? Next. So according to the Newton's law of shear, you can say the shear stress is directly proportional to shear strain. The shear stress acting on the body is directly proportional to shear strain. So that means tau is directly proportional to, we will discuss in next slide in detail. The shear stress is directly proportional to shear strain. So before that, I will show you, this is the velocity distribution function. See, if you see here, the water is flowing. So when the fluid particles contact with the solid surface, so what will be the force acting here? This is called adhesive force. We already discussed. This is called adhesive force. So when the fluid particles contact with the solid surface, so the fluid particles will gain the velocity of the solid surface. The fluid particles here will gain the velocity of the solid surface. So this is a fixed, right? This is a fixed plate. So the velocity here is 0. So what are the fluid particles contact with the solid surface will be gain the velocity as 0. That's why the velocity triangle here it is 0. So it is 0. Velocity triangle here it is 0. So next, if you go up, when you go, I am going here, second particle. So when you go up, still there is an adhesive force between the solid surface. So this influence will be here, right? But it is less because it is some distance away from the solid surface. So because of that, the velocity slightly increases. If you go up, what will happen if you go up? The molecular attraction between the solid surface and water particles will reduce. So then what will happen? So the velocity keep on increasing. At some distance, the velocity, there is no influence of the solid surface. So that you can get the velocity of the free stream velocity, that is u. So this is the velocity profile. You can call it as this is a velocity profile. This is a velocity profile. So there are two types: linear velocity profile, non-linear velocity profile. Normally in natural, if you see real condition, it will follow the non-linear relationship. But for simplification, sometimes we can assume it as a linear. So why it is 0 here? Because of the liquid molecules contact with the solid surface, because of the adherence, contact the solid with the, what are the fluid particles contact with the solid surface will gain the velocity of the solid surface. So here solid surface is fixed, that's what the velocity is 0. For example, if you throw a duster like this mobile plate, duster, if you throw the duster, so when the fluid particles contact with this solid surface, will gain the velocity of this duster. If it is moving with the velocity u, so these fluid particles, when they are contact with the solid surface, will gain the velocity of u meter per second, right? Okay. Yeah. Now, so now I am drawing the velocity profile. Yeah, if you see here, so this is the solid surface or fixed plate. So when the fluid particles contact with the solid surface, the velocity is 0. So the velocity slowly it will increase, and somewhere it will reach the velocity as u, right? So I have considered at some distance y from the free surface of the liquid, the velocity is u. So away from that distance, I can consider some distance away from that y point, that is dy, where the velocity is, here it is velocity u, because of it is away from the solid surface, the velocity will increase, right? So the change in the velocity is du, so therefore total velocity is u plus du. Total velocity is u plus du. So what we have discussed, according to Newton's law, the shear stress is directly proportional to velocity gradient. Sorry, shear strain, right? The shear stress directly proportional to shear strain. So what is shear strain here? Change in velocity by change in distance. So the shear stress is directly proportional to du by dy. The change in velocity with respect to change in distance. The change in velocity is du. With what distance? This is the change in velocity. The change in velocity is du. The change in distance is dy. So du by dy you can call as a velocity gradient. So this du by dy you can call as a velocity gradient. So that means how the velocity will vary with respect to some distance from the mobile plate. Okay, therefore we can write shear stress is directly proportional to du by dy, where this proportionality, so I can replace this proportionality with some coefficient, so that I am representing with mu. So du by dy, this mu you can call as a dynamic viscosity or simply viscosity. This mu you can call as a dynamic viscosity or simply viscosity. Okay, is it clear? Okay, now what is the units? So we know that shear stress units Newton per meter square, and mu dynamic viscosity units we have to find out. Velocity units meter per second, and distance dy means in meters. So meters will cancel. So the dynamic viscosity units are Newton second per meter square. The units are very important in fluid mechanics. So mu dynamic viscosity units are Newton second per meter square. In CGS units you can show it is as a poise. In CGS system we will show dynamic viscosity as a poise. So what is poise? You can say 10 poise. Okay, you can say 10 poise will be equal to 1 Newton second per meter square. That means 1 Newton, okay, 10 poise is equal to 1 Newton second per meter square, right? So that is the formula we will, this is the formula to convert Newton second per meter square into poise, because in few problems they will give in poise and few problems they will give in Newton second per meter square, and he will ask you to find out the dynamic viscosity in poise. So it is better in the problem you have to show in the both units. Okay, so 10 poise is equal to 1 Newton second per meter square, right? So then this conversion we will discuss in detail. This viscosity is also defined as the shear stress required to produce rate of shear strain. So what is viscosity here? If you see the shear stress, what is the shear stress required to produce the rate of shear strain? So that is also, you can say in another way, what is the dynamic viscosity. I hope you understand this concept. Now we will try to solve some numerical problems, and before that we will try to understand factors influencing the viscosity. If you see pressure and temperature influence on viscosity. Yeah. Pressure and temperature influence on viscosity. The pressure have very little or no effect on the viscosity of the fluids. The pressure, so if you apply the pressure on the fluid, whether it is influence or not, yeah, it will influence, but it is very little, so that you can neglect. So we can avoid the influence of the pressure on the viscosity. But how the temperature will affect? If you see the effect of temperature on viscosity, how the temperature will affect? If the temperature increases, what will happen? The viscosity of the liquid is due to temperature increases. What will happen? What is happened to the viscosity? So then we will try to understand the viscosity of the liquid is due to cohesive force. We already discussed. What is the cohesive force? The cohesive force is the molecular attraction between the same molecules. If the temperature increases, what will happen? The force between the molecules will decrease. The temperature increases, the cohesive force decrease. If the cohesive force decreases, what will happen to the viscosity? Viscosity will decrease. Why? The temperature increases, the molecular attraction between the molecules will decrease. When the molecular attraction will decrease, so the viscosity will also decrease, because the molecular attraction is the reason for viscosity. It is for the resistance against the flow, right? Okay. So next, effect of temperature on viscosity of the gases. So how the effect of temperature on viscosity? We all know, if the temperature increases, what will happen? The molecules will move faster and the molecular activity will increases. If the molecular activity increases, viscosity increases, right? In case of gases, it will be different. The temperature increases, activity will increase. If there is more activity between molecules, the viscosity will be more. Okay, clear? So see, again I will summarize. The temperature increases, cohesive force between the molecules will decrease, so which leads to decrease in the viscosity. The temperature increases, molecular activity increases. If the molecular activity increases, then it will offer more resistance to the flow, so viscosity will increase. Now we will try to solve some numerical problems. Yeah, this is the dynamic viscosity for different fluids. If you see, the air has 18.3 into 10 to the power minus 6. This is the viscosity of the air in Pascal second. Pascal means Newton per meter square, Newton second per meter square. So the same units. The water has a viscosity of 0.28 in 10 power of 3. And if you see, mercury have higher viscosity than the water. We will try to solve some problems. Okay. We will try to some problems related to viscosity. Yeah. Now we will try to some problems related to viscosity. First I will try to read the problem. A plate of 0.025 mm distance apart from the fixed plate. So there is a fixed plate. So there is a fixed plate which is a plate to 0.025 mm distance from the fixed plate. So there is another plate. There is another plate. Here the distance is y, right? Here the distance is, can say 0.025 mm. Okay. Moves with a velocity of 60 meter per second. So this is moving with a velocity of 60 centimeters per second. 60 centimeter per second. And requires a force of 2 Newton per meter. 2 Newton per unit area to maintain this speed. So we have to apply a force of 2 newtons per meter square area. So this is the stress. So we have to apply 2 Newton force per meter square area to maintain this speed. If the plate has to move with the 60 centimeter per second. So he asks you to find out fluid viscosity between the plates. So there is a fluid flowing between the two plates, and we have to find out the viscosity, dynamic viscosity between the fluid plates. So how we are going to solve this problem? First, what you have to do is, first you have to write the given data. What is the data is given? First, y is given 0.025 mm. This is nothing but dy, right? Distance between the plates. That is 0.025 into 10 to the power of minus 3 meter. So I am converting this mm to meters. So after that, next we need to, what is given? Velocity. U is given 60 centimeter per second. So that we have to convert it into meters. So 60 into 10 to the power of minus 2 by second, meter per second. So what is the du? Change in velocity. Initial velocity is 0, final velocity 60 meter per centimeter per second. So thus the du is change in velocity 60 into 10 to the power of minus 2 meter per second. Next, force is given 2 newtons and area is given. So we have to apply 2 Newton per meter square area. That means 1 meter square area you have to apply 2 newtons. The stress tau is equal to 2 Newton per meter square, right? 2. So what is the relation between the shear stress and dynamic viscosity? Tau is equal to mu into du by dy. So what is shear stress is given 2 Newton per meter square will be equal to mu. We have to find out. So this we know, and this you know, this you know, this is unknown. This you have to find out, right? So mu into, what is du? Du is 60 into 10 to the power of minus 2 by what is dy? Dy is 0.025 into 10 to the power of minus 3. This is meter per second and this is meters. So meter will cancel, and this is Newton second for meter squares, and mu value is, so if you solve this you will get the dynamic viscosity. Clear? If you solve it you will get viscosity. Now the final answer will be, you will get how much? So you will get 8.33 into 10 to the power of minus 4 poise.